Aloha kako. Up until now, we've been talking about generic methods. We've been talking about generic methods and type bounds. So in this lesson, we're going to be talking about generic classes. So without further ado, let's go ahead and jump into the Zybooks. So when we're talking about generic classes, we're talking about cases where we've got similar classes. They may differ only in like the types that are used in the class fields and some of the methods. So the good news is we can replace all these redundant classes with just one that's going to work with various class member types. So this is good. It keeps with our dry principle, which is do not repeat yourself. We're going to be able to use just the single one, and then if we need to make changes, we're not going to have to do that across, multiple ones for different types. So that's great. So a generic class is defined as a class with type parameters that can be used in place of types to define the class's members. So we're going to take a look at one example down below, and we'll go ahead and take a look at our participation activity. So our participation activity, we're going to pull it up here. We'll go ahead and start. We're looking at something here. We've got a pair of ints and pair of doubles. You'll notice that the things that differentiate these two is simply the type of pair it is. An integer over here, we're using the integer for our fields. We're also using it for our inputs in the constructor, and the same over here. It's just double for these. So obviously, looking at this, you can see that we can abstract out and use a type parameter for that. So we go to the next step, and it says generic pair class can support item pairs of any class type, including integer and double. So we go ahead here. We've got our abstracted out generic type here. So we're just going to call it pair instead of pair of ints and pair of doubles. We're just going to call it pair. And then you see that we're taking item type. We're doing that in our brackets again. So we've got item type defined there. And then we use item type as the definition of our fields, as well as the input types in our constructor class. So moving on to the next step, it's just going ahead and rehashing that. Item type is a type parameter that can represent any class type. A class definition can use the type parameter as the type for class fields like item 1 and item 2 that we have here. And a generic classes type parameter can also be used as the type for a method's parameters or return type. So yeah, so you can see that here. And the pairs constructor uses item type as the type for the value 1 and 2 parameters. So just as we mentioned. So going and looking here at our participation activity, can the above generic pair class replace the given class? So we're going to look here. We're going to see public class myPair, got private double item 1 and private character item 2. So you'll notice that these are separate. So I'm going to go with no here. And that's right, because the generic pair class requires fields of the same class type, so pair cannot replace myPair. So we've got public class pair string, we've got private string item 1, private string item 2. Does that look good? Well, we see that they're the same type, so let's try yes. And you'll see that, yes, both fields in the pair string are strings. The string is a class type, so the generic pair class can replace pair string. So for the next one, public class pair char int, private char item 1, and then private integer item 2. Again, we have differing ones. So that's going to be a problem. And also, this is this is a primitive, so we're going to have issues there. So yes, pair char int has fields of different types, and item 1 is of a primitive char type. The generic pair class, and remember this, the generic pair class requires fields of the same class type, so pair cannot replace pair char int. So yes. So public char pair of numbers, we've got private double item 1, private double item 2. Again, the issue that I mentioned here, we're not using classes here, we're using primitives, so I would say no. And yes, it has fields of primitive double type. The generic pair class requires fields of the same class type, so pair cannot replace pair of numbers. Then we get into using a generic class's type parameter and member methods. Okay, so choose the correct replacement for the missing code below. So the generic pair class has methods to get and set the item 1 and the item 2 fields. Okay, let's take a look. We've got public class pair with item type. Then we've got it defined with item type, good. So we're going to have something here for get item, return item. Then we're going to have something here for get item and item 2. So we know that item 1 is item type, and we know that item 2 is also item type. So let's go in here. So A, we know that this is going to have item type as the, oops, sorry, it's got item type as the type. So then we have for B, we're going to be looking at set items. So we've got the value here. So again, we're going to go with, oops. So yeah, so for here, we're going to use the item type. So yeah. So anyhow, the type of the value parameters must be item type so that the set item 1 and set item 2 work for various class types. Okay, so using a generic class, a programmer can so now that we've created it, now how do we instantiate it essentially? So a programmer can instantiate a generic class by appending the type arguments to the class name in angle brackets. So you pair, and then in angle brackets you can have the type. So we're doing string here, then username equals new pair, again in brackets string, and then we're going to use our we're going to put in our constructor values there. So that declares a username variable that refers to a pair of strings in this example. And then we get into the participation activity. So let's go ahead and take a look at this. This is going to use our generic pair class. And we're looking in here. So the program defines two string arrays and generates a random index into each array. The program creates a username, prefix, and suffix from the random indices. So what we see there, so over here, we've got a random number generator. It's just creating it's creating random here. Then we're going to go ahead and we're going to set up two different arrays with our strings in it. And then we're taking right here, we're saying words 1. So the prefix we're going to take from words 1, from this array. We're going to go ahead and array of strings. We're going to go ahead and take a random from our rand generator. We're going to go ahead and get next int. And that's going to give us, using the words1.length, that's going to give us the length of this, which is 1, 2, 3, 4, 5, 6. So it's going to give us a value between 0 and 5, and we'll use that to grab something from here. So it's going to do the same thing on words 2. So we're essentially grabbing a random entry from each of these. And one is going to be prefix, the other is going to be suffix. And then we're going to go ahead and we're going to create our pair up here. We're going to say pair, we're going to go ahead and say pair of string. So we're going to make it of type string. And we're going to say username equals new pair string. We're going to give it prefix and suffix. And then we're going to go ahead and we're going to print it out. And the printout is going to be using the toString over here, which is going to give the first name and the last name, or not the first name and last name, but the prefix and the suffix. So, I guess we could continue this here, but it says the username is assigned to the new value, as we mentioned. Yeah, is there anything of interest there? No. Then the compiler uses the string type argument for the item type parameter. So username refers to a pair of strings, which we talked about in our last generic section. Then the toString method with the pair class returns a string that combines item 1 and 2. For the username object, item 1 refers to deft and item 2 refers to bagel. So yay for that. So the built-in generic classes. So Java's built-in collection classes like ArrayList are generic classes. So for example, you can do ArrayList of integers. Nums equals new array list of integers. And that uses an integer type argument to create an array list of integer elements. We've done this before. A programmer creates array list of different element types by using different type arguments. So we were doing that all the way back in the first section of generics. We were doing strings and integer, and I think double as well. So now the participation activity wants you to mix and match things here. So let's take a look. So start with the shortest pair of double range. So this looks like it's going to create a pair of doubles, declared an uninitialized variable that can refer to a pair of doubles. Yes, and then we're going to take the next shortest one just because I'm lazy. So pair of words equals new pair string to and by. So this looks problematic to me because we're not putting anything in the pair. And luckily we have a statement does not compile, so that worked out right. And the nice thing is it tells us why these answers are correct under it once we put that in there. So imagine if we put it into the wrong one, it would give us more guidelines on that too. Nope, it didn't. Not there either. So yeah. So anyway, omitting the type argument from a declared variable's type results in a compiler error. So thanks for letting us know. So now we've got pair of strings, and we can just look over here and tell automatically that we're talking about a pair of strings right there. So the string type argument is missing from pair to by, but the Java compiler infers that missing string type argument from the type of the words available. So that's a new thing that it doesn't explain up above. It's nice we were able to tease that out from the problem here. So then, but it does follow kind of what we did in previous sections on generics, where it's inferring, the compiler is going to infer from the actual arguments that are sent in. So then we've got a pair of character letters, so it can only go in one place. Since we got all the others right, it has to go here. But when we go ahead and dump it here first, let's look at it. So we're setting up a pair of character letters and equals new pair of character A and E. Yep, so that creates a pair object for characters. Yep, so it's a character is a class type, so the generic pair class supports the character type argument. So we're good. Now, generic classes with multiple type parameters. So just like before when we were talking about generic methods, we start out with just one type being sent as a parameter. We can also do multiple types here. So that makes it easy if we have different aspects. If we have a complex class where we're dealing with, relationships between things of different types. So this is kind of cool. So a generic class may use more than one type parameter, and like before, comma separates the type parameters in a class definition. So you can have class pair, and then in your angle brackets, you'll put item type 1, item type 2. So you can have like string and double, string and int, string and double, whatever you want there. And that's going to define a pair class with, for this example, that would define a pair class with two type parameters. So comma separates type arguments when defining a variable for a generic class with multiple type parameters. We mentioned that. So you stick in two, you just separate them by a comma there. So yeah, it's easy enough. And here we have an example. So defining and using a generic pair class with multiple type parameters, we'll go ahead and hit start on it. And generic pair class with a single type parameter has fields item 1 and item 2 of the same type. So we see that. We've got item 1, item 2, they're both item type. So you can create one where you're going to actually separate these. So you can have item type 1 and item type 2. So a generic pair class can be defined with two type parameters, item type 1 and item type 2, like I said. And here's what that looks like. So then you can have item type 1 defining your field item 1, and then item type 2 for item 2 here. Then the field item 1 is of item type 1, item type 2, as we just mentioned. Yeah, so easy enough. And then the class's constructor and member methods use the item type 1 parameter for item 1 and item type 2 for the parameter for item 2. So you look up here and you can see that on the constructor, this is our constructor. We've got item type 1, item type 2, and then for our getters, so you often talk about getters and setters, like a method to get the value of the object, a method to set the value. Over here for getting, we're going to return the proper type for it. So we've got our item type 1, item type 2. And then a programmer appends type arguments separated by a comma to the class name to instantiate the generic pair class. So this is what it looks like down here. So when you're going to instantiate something, let's call it key and value will be the name of the object. We're going to say pair string integer, our variable name equals new pair string integer with x, y, and 2. So it knows what types to use there, string and integer. And then it can go ahead and print line key and value to string. So it's going to go and grab the to string and then output the first comma, space, and then the second one. So it shows that down here. Then defining methods in a generic pair class with multiple type parameters. So this is pretty straightforward. We just go in here, look at it, choose the correct replacement for the missing code below. So the above generic pair class has methods to set the item 1, item 2 fields. So we look at here, set item 1, something value 1 equals, item 1 equals value. So when we look at that, and then we have for 2, we're going to have the set item what type, and then value 2. So when we look at item 1 here, item 1 we know is item type 1. So A is going to be item type 1. And then for the second one, item 2, we're setting it over here. So value 2 is going to be tied to the item type 2. So that is not exactly brain surgery. Now, using a generic pair class with multiple type parameters, so consider the above generic pair class with 2 type parameters. Which type arguments do not compile? So double double should, because even though we have them treated as separate ones, it's fine to do double double. Double integer, that should be fine because we're using 2 different ones. Double int, though, again, we come back to that idea that we can't mix. We need classes here. We don't need primitives. So if you click here, yes. So, they must be class type. So using int as a type argument fails to compile. So then fill in the blank. We've got pair of string and integer, my new pair. So we're instantiating here, essentially. So we're instantiating. And then here it's okay for this to be blank because it's going to infer this. So it knows that we're going to be using a string. So a string and an integer here. So what is going to be for get item 1? So we're going to my pair and we're going to get item 1. So we need to look and see what what the first one, the first value corresponds to. So the first value is going to correspond to item type 1, which is the first one. And the first one in that example is going to be string. So we say string, and that's correct. So fill in the blank, pair of string and integer, my pair equals new pair, again blank because it's inferring it from here. So then for item 2, what is the value? So it's not string, it's going to be the integer. So we click here and integer is indeed that because it matches up with item 2. Because we're having to set the internal variable here and it's got to accommodate the get item 2. And when we look up get item 2 over here, we can see that it's using the second parameter type. Okay, postage cost calculator. So this is really interesting. What we can do with this is we can create what in other languages we call dictionaries. So you'll hear about dictionaries where you're associating keys with items. So if we're doing something like this with this pair class that we're talking about, we can create dictionaries in a way. Dictionaries can be used for anything. A dictionary, they get that because you have a word and then it has meaning, but you can use it to also keep, let's say, if you're dealing with, let's say you've got a program that has configuration values. You can have your configuration key and then your value for it. So you can set up a bunch of different things that way. Anyway, in this example here, we're going to be setting up a list of pair objects for postage. So on the one hand, we're going to use weights for, I think, weights and ounces. And the other thing we're going to have is cost. So the cost of the postage for that. So here, when we look at our code, we've got 2 different ones. We're setting up our custom class here, our generic class and pair in one file. So we say public class pair. It's got item type 1, item type 2, and it does pretty much everything that we saw previously. It's got our getter and then our display here. And then in our postage calc.java, we have a scanner here that we see. We're going to be dealing with ArrayList, it seems. So postage calc, when we call this, we're going to set up that scanner to input things. Then we're going to say that ArrayList is, so we're creating an array list of pairs. So our class that we have, we're going to essentially have an array list of these pair objects. and it's going to be called weight costs. And then we say new array list to set that up. And then we're going to add items to it. So we're going to add a number of these new pairs. So we say weight cost.add, which is adding to this array list. We're going to say new pair, and we're going to say it's a double and an integer. And the first number, the double, is going to be 1.0, and that's going to be the weight. And then the integer part is going to be 49. So we've got new pair, double integer here. One, we're doing the we're calling the constructor here. So we're setting it up to be a weight of 1 ounce in 49 cents because I think this is, it says up here it's a postage cost in cents. So you'll see that we're setting up this thing. Notice this is ascending. So this is going to be a hint as to how we're going to be using this shortly. So then we have a double here, user letter weight, Boolean found weight, integer I. So we're going to send out a message to the screen saying, hey, enter the letter weight in ounces. And they're going to put in the amount, like 3.2 or something like that. Then we calculate the postage based on the smallest letter weight greater than or equal to the mailing letter weight. So in other words, if we put in 2.5, we're actually going to need to get the one for 3. So the way we're going to set up our loop here is where all the magic happens. So we have a for loop right after this. In the for loop, we say for I equals 0, and we're going to go while, let's see. Yeah, so we're going to do this while I, in other words, the index here is less than the weight cost dot size. So in other words, while we're still, looking at weight cost, if we have 10 weight costs there, I don't know, I didn't count, but if we have 10, while our index is under 10, or under actually 9, while it's still under that number, and we have not found the weight because we set up found weight here to be false. So we're saying that we haven't found the correct weight yet. So as long as we're still in this array here, looking at items, and we haven't found it yet, we're going to keep looping. So then our logic in the loop is if the user letter weight, let's say you put in 2.6, is less than or equal to the weight cost for the current one for their current ones, the item there. If it is less than or equal to it, then this is the one that we want. So we go ahead and hold on. I'm being distracted here because I've got a hands up in here, which I don't understand why. I think I turned on hand signals here, so I apologize for that. But anyway, getting back to here, if the user letter weight is less than or equal to the weight costs, this one, get item, then we're going to say, okay, this is the one, found weight is going to be true, so we can kick out of this loop. And then we're going to print out the postage for the USPS first class mail is, then we actually go ahead and get out the value from here, okay? So on the first one, we're just getting the weight cost dot get of I dot get item 1 is going to give us the value of the weight in ounces, and then if our user letter weight is less than that, then the found weight is true. We're going to print out the amount that it costs, which is the second item in there. So hope that makes sense, and then we print out the cents after that. So let me go through that loop just one more time, just to make sure it's crystal clear. So what we're doing here is we're saying, okay, within this array, we're traversing the array list here, going through all of our pairs that we have, our pairs of weight with cost, and we're saying, as long as we're within that, so the I less than the size, saying as long as we're still in that array and we haven't found the weight, keep on looping. So then the if statement here is saying if the letter weight is less than, and we're going to get, for the current index that we're in, I, we're going to get the weight, and we're going to say, is our letter weight less than that? So is our 2.6, if we entered that, is that less than the current one that we're looking at? And if it is, then hey, good, this is the one we need. So found weight, true now. We don't need to keep on looping. And then we say, okay, here is our associated cost with that weight. So we go to weight cost, get I, get item 2. So that's how we get the the actual cost of it. And then we print out cents after that. So if we go through everything and we still haven't found our weight, then we say letter is too heavy for USPS first class mail. So yeah, so that's how this runs. They show examples of it right here. So that was a long example, but it shows you how you can effectively use that pair object. You can do this with all kinds of stuff. You can use that as like a generic dictionary, if you will. There are better ways of doing it, but this is one way that you could use it. So our participation activity using a generic class in the above postage cost program. And this is really just kind of looking up stuff, but what does the pair object and weight cost of 0 represent? So weight cost of 0, so if we look at weight cost, remember what weight cost is. So weight cost is going to be it's going to be a pair combo for the first item. So so in our example here, so it's going to be essentially 1 and 49. So it says so it's going to be a 1 ounce letter because the first one is the weight and the cost is 49 cents. So we click here and it says, the first pair in the item is the letter's weight and the second item is the cost. So what is the postage cost of a letter that weighs 2.5 ounces? So we have to go back up to our list, 2.5. Remember, we go until we hit the one that it's less than. So that's going to be this one. So it's going to be a cost of 91 cents. So you put that in there. If you want to understand why it's not these others, you just click on those as well. It'll explain to you that, it's the smallest weight that is greater than or equal to 2.5. So that helps. If a letter's cost was a double with units of dollars, which option creates a pair object for a 1 ounce letter that costs 50 cents? So let's think about that. So we're talking about a double for our weight, so 1.0, and we're talking about now a double for the second value in there. So automatically we know it's double double, so that's going to be the second or the third one. But then we're talking about units of dollars. So when we're talking about dollars, if we look at 50 cents, 50 cents is not going to be 50.0 because that's going to represent $50. So it'd be 0.5, which would be 50 cents, half a dollar. So we go with the third one. So that checks out. And then we get to challenge activities. So we go ahead, enter the output of generic classes. This is another thing where you just have to look through it and try it out. So if we run this, it's got our pair thing defined over here, so we may have to look back at it. So pair manager, so it's asking what the output is. Again, if we look at pair, like for the printing of it, there's nothing about printing it here. Oh, but we're doing print lines, so remember to put an enter after it. So if we were to do, all right, so let's look at this. We're going to print out 2 ints. So 2 ints is going to look like pair of 35 and 21. So when we do a toString, that's going to look like 35 and 21. So we'll put that in as 35 and 21, and then enter because it's a print line. And then we look at the 2 doubles. 2 doubles is going to be 24.6, 26.6 and 46.3, and the enter because it's going to be kind of inattentive there. So then we hit check. Oh, and that is correct. So I think the second one is the same way. Yeah, you just have to pay attention here. Go ahead and try this out on your own. The nice thing is it's going to ask you for different variations here. So if you wanted to go back and look at the thing over again, I think it'll give you different values. Yeah, like here, it's I think this is different values from what we saw before. So you can test yourself over and over on it just to make sure that you're getting the concepts. Here we have generic classes. Complete the declaration of the generic class flight report with 2 type parameters named LM1 and LM2. Again, this is going to be kind of like in the last section where we were doing it, where you need to go over here and finish the public class definitions. So you're going to be deleting the code there. So it tells you everything up here that you're going to have to do. So complete the declaration of the generic class flight report. So we know it's flight report, and we know that we're going to need to put in uh, our two things there. So lm type 1 and lm type 2, respectively. Okay. So public class, is that correct? I think that is. So if we do a check on it, yep, so that passes. So it's going to ask you a series of these things. So go to the next one, and it's going to show you, yeah, complete the declaration of the generic vehicle class with two private fields named element 1 and element 2, both of type data type. So you're going to do the same thing here. So but it's the nice thing is it's asking you about different parts of it. So through doing this, you're going to learn how to construct the class properly. Then you're going to learn how to do your fields correctly, and then it may ask you for the actual constructor. It may give you like a blank thing over here, or maybe it'll just blank this entire thing and have you come up with those values. So use this to test that knowledge. And again, I think it's such that if we were to go back to like level 1 and do it, it'll ask us to yeah, so here it's asking like a vehicle info one. So you can keep on testing yourself over and over just to make sure that you understand the concepts and get used to the syntax that's used for the public class, the constructor, and using it with the fields up here. So anyway, work through this, and that is really all there is to our generic classes intro here. It's a little bit long, but yeah, hopefully you'll enjoy this section because this is going to be quite useful. So if you have any questions, as always, reach out to me, send me an email. I'd be happy to explain it to you, talk to you in a Zoom. Just reach out, and if not, I'll see you in the next video. Aloha.